Let me ask you a question. Have you ever seriously thought about it? Does death really mean the end of everything? For hundreds of years, we have been asking who we are and where we go after we die. Is there an end to consciousness? Philosophers, scientists, and believers have all offered different answers. But among them, one viewpoint from modern physics is truly staggering. It's called quantum immortality. It might sound like science fiction, but it is actually based on a serious physical theory, the many worlds interpretation. This theory boldly proposes that every time we face a life or death moment, the universe splits into countless parallel versions. And in some of those versions, you didn't die. Your consciousness will continue to exist in those worlds where you survived. In other words, the self you perceive may never actually experience death. This isn't a belief in an immortal soul, nor is it metaphysics. It is a mind-boggling possibility that emerges from the quantum world. It challenges our understanding of life, death, and even reality itself. If death isn't the end, then what does it mean to be alive? Next, we will embark on a journey that will upend your imagination to unveil the mystery of quantum immortality. We will not only explore the hard, scientific principles behind it, but also delve into what it means for life, death, and even existence itself. You will see some astonishing experiments, bizarre theoretical concepts, and even some visual scenes that could change your perception of reality. We will do our best to take this seemingly distant and abstract concept and bring it back to a daily context you can truly understand and even relate to. By the time you reach the end, perhaps you will not only rethink what happens after death, but you will also turn back and ask, what is the meaning of being alive? But to truly understand quantum immortality, we first need to build a foundation and step into a world that seems a bit crazy, but is very real. Quantum mechanics. This branch of physics specializes in the behavior of extremely tiny particles. And on that scale, the rules of reality almost completely defy intuition. For example, particles can exist in multiple states at once. Events don't have definite outcomes, and observation itself affects reality. Doesn't that sound a bit like magic? But it is. In fact, one of the most accurate and profound parts of modern science, and the core of quantum immortality, slowly emerges from these very strange phenomena. In the world of quantum mechanics, what's most fascinating is perhaps not its experimental phenomena, but the interpretations behind them. One of the most controversial and imaginative theories came in 1957 from a bold idea proposed by a young physicist, Hugh Everett, the many worlds interpretation. This theory says that every time a quantum event occurs, all possible outcomes happen simultaneously, but in different universes. In other words, the universe, at every moment of choice, infinitely splits into countless parallel universes. For example, if you flip a quantum coin, in one universe, it lands on heads, and in another universe, it's tails, and you exist in both of these worlds, just experiencing different outcomes. Sounds like science fiction, right? But it is one of the most discussed theories in quantum physics, and this framework is the very foundation of the concept of quantum immortality. In the early 20th century, scientists discovered that classical physics simply couldn't explain certain microscopic phenomena. Why is there a limit to thermal radiation? Why do photons behave like both particles and waves? Why don't electrons in an atom move like planets? And so, Planck proposed that energy isn't released continuously, but in discrete packets, one by one. When Einstein studied the photoelectric effect, he went even further and boldly proposed that light is actually composed of particles called photons. These discoveries shook the centuries-old foundations of Newtonian mechanics. The world was no longer a completely predictable machine, but a probabilistic space filled with possibilities. From that moment on, physics was no longer just describing reality, but questioning what reality truly is. although Schrödinger's cat is often used to illustrate the strange phenomenon of superposition. Today, let's try a fresher and more human analogy. Imagine you walk alone into a dense forest and stand at a crossroads where you can't see the end. There are two paths before you. One leads to safety, the other hides danger. The moment you take a step forward, the universe silently splits around you. In one world, you take the safe path. In another world, you step into a perilous fate. The staggering implication of quantum immortality is that it suggests your subjective consciousness will perhaps always flow into the branch of the universe where you survive. In other words, from your perspective, you are always on the path that keeps you alive. This idea pulls abstract quantum theory from the cold world of particles back into our everyday experience. It's no longer just about formulas and laboratory wonders. It becomes a story about you. It asks us a deeply moving question. When death is near, do we really come to an end? Or could it be that our consciousness unknowingly slides into another reality where it continues to exist? Quantum immortality is not just a physical hypothesis. It touches upon humanity's deepest philosophical puzzles. Why do we exist? Is death really the end? And what does the self we speak of truly mean? In traditional views, death is the end, the extinguishing of consciousness, the complete disappearance of the self. But the idea of quantum immortality challenges all of this. It suggests that perhaps, from a subjective standpoint, you will never experience the event of death. Whenever life reaches a critical crossroads, your consciousness may always leap into the branch of the universe where you survive. This raises a stunning question. Is death an end? Or is it a smooth, silent transition between universes? If we do possess such a continuity of consciousness, then does the clear line between life and death actually even exist? Furthermore, if consciousness can survive across universes, then is it really just an electrical signal in our brains? Or could it be a fundamental structure of the universe itself, as real as space-time? These questions are no longer just idle thoughts for philosophers, but are tangible frontiers of exploration. At the forefront of science, consciousness, existence, the structure of the universe, the relationship between these three may be far more profound than we imagine. What's more complicated is that quantum immortality is not just a hypothesis about life and death. It also brings up some unexpected ethical questions. For example, if every decision we make creates a brand new branch in a different universe, then are we also responsible for the consequences in those branches we don't get to see? Another example, if some form of immortality truly exists, would we still revere life and cherish the present moment as we do now? Or would it make us treasure every choice in this moment even more? Because we are creating countless possible lives, quantum immortality is not just a scientific concept. It attempts to reshape our philosophy on life, our values, and even our worldview. These ideas not only make us rethink the end of life, but also bring responsibility, morality, and the fundamental question of who I am into an unprecedented, multiverse context. If your consciousness truly splits into countless branches, how should we define the self? Does the existence of countless versions of you blur the meaning of the individual, or even diminish it? Or is it just the opposite? Does every moment become unique and filled with deeper value because of it? These debates show that quantum immortality is not just a concept in physics. It profoundly affects our understanding of existence. Basic particles like photons or electrons, depending on how you observe them, can behave either like particles or like waves. It's as if you asked someone whether a coin is heads or tails, and their answer actually changes depending on whether you're observing it from up close or far away. The most famous experiment behind this is the double-slit experiment. Scientists fire a beam of electrons at a barrier with two slits. Behind it is a detector screen to show where the particles land. Case 1. When you observe the particles passing through the slits, they behave like tiny marbles, passing through only one slit and landing on the screen. Two formed distinct lines. Case 2. When you don't observe their path, the particles spread out like waves and form a pattern on the screen similar to the interference of water waves. This implies that they seem to have passed through both slits at once and interfered with each other. This sounds absolutely incredible. Simply put, it's like you reach a fork in a forest path when no one is watching. You walk down both paths simultaneously, like a ghost, exploring all possibilities. But as soon as someone looks at you, you immediately choose just one path, as if to respond to that gaze. Why is this so staggering? It seems to imply that the mere act of observation changes reality. So if no one is looking, what does the world become? Does the observer shape reality? Or does reality itself include the observer? In the world of classical physics, things are always one way or the other. An object is either here or there. A coin is either heads up or tails up. But quantum mechanics shatters this intuition. It introduces an almost incomprehensible concept: superposition. In the quantum world, a particle, before being observed, can exist in multiple states at once. It's not that we don't know where it is. It's that it literally exists in all possible states. To illustrate this, physicist Schrödinger devised a seemingly absurd thought experiment. Schrödinger's cat. Imagine this scenario. A cat is placed in a sealed box. Inside the box is also a radioactive atom and a vial of poison. If the atom decays, it will trigger a device that breaks the vial, and the cat will die. If it doesn't decay, the cat remains safe. According to quantum mechanics, the atom, before being observed, is both decayed and not decayed. Therefore, the cat is also both alive and dead, existing in a state of superposition. It sounds absurd, but that is precisely the logic of the quantum world. We can use a simpler analogy to help understand. Imagine you toss a coin and then seal it in an envelope before it lands. As long as you don't open the envelope, the coin, to you, is both heads and tails. Both states coexist. Only at the moment you see the result does it choose to become one or the other. What does this all mean? It challenges a belief we take for granted: the existence of objective reality. If a particle doesn't have a definite state before being measured, can we still say that reality exists before we observe it? Superposition raises an unsettling question. Is the world we see just the version selected by our observation? From among all possibilities, perhaps the universe is not inherently clear and definite, but is filled with overlapping, ambiguous, and even infinite possibilities, until we cast our gaze upon it, and reality freezes into the form we know. In the quantum world, there's a mysterious phenomenon that looks like magic, but actually stems from nature's deepest laws. This is quantum entanglement. When two particles interact in a certain way, they become inseparable, entering an entangled state, no matter how far apart they are. Even if they're on opposite sides of the universe, the state of one particle instantly determines the state of the other. Albert Einstein was unsettled by this, calling it spooky action at a distance, because it seemed to violate a fundamental rule of the universe. Information cannot travel faster than the speed of light, but countless experiments have proven that this strange connection is real. We can use an analogy to simplify it. Imagine you have a pair of gloves. You send one of them to the distant moon, while keeping the other on Earth. You don't know which is the left and which is the right, but once you open the box on Earth and see it's a left-hand glove, at that very moment, you instantly know that even 380 kilometers away, the glove on the moon is the right-hand one. However, quantum entanglement is far stranger than this analogy. In quantum entanglement, the states of the particles are not predetermined. They are only determined when observed. And once you observe one of them, the state of the other immediately takes form, no matter where it is in the universe. What does this imply? It challenges our concepts of causality and space. Do we need to accept the fact that, in the universe, there exists some hidden connection that transcends space-time? A deeper order hidden behind our reality? If observing one particle can affect the state of another distant particle, are we, in some way, participating in the shaping of reality? Perhaps we are not bystanders in the universe, but co-creators of reality. Every glance, every decision, plucks a string deep within the cosmos. This is a question worthy of deep thought for every one of us. When we stop looking, does reality still exist? In the bizarre world of quantum mechanics, there is a shocking discovery, the observer effect. It tells us that the mere act of observation is enough to change the state of a quantum system. This is not science fiction. It is the result of real physics experiments. Remember the double-slit experiment? When we don't look, particles spread and superimpose like waves, as if passing through both slits at once, exploring all possibilities. But once we start to observe, they suddenly become well-behaved, choosing a single path like little balls. Is this a coincidence, or some deep rule of the universe? Imagine you're trying to catch a butterfly in the wild. Every time you get close, it flutters its wings and flies away, changing its direction. But if you stand there quietly, it dances gracefully in its natural way, undisturbed. At the quantum level, particles are like that butterfly. The moment we observe them, they change. This leads to a powerful philosophical question. Can we say that this world truly exists independently of us? Or does the universe only decide its state when it is being observed? This is an echo of solipsism, an ancient philosophical idea that only the observer's mind is certain to exist. The external world is subject to verification. And in quantum mechanics, reality seems to echo this view. When we don't look, the world is just an ocean of possibilities. When we gaze upon it, it solidifies into some form of reality. What does this mean? Is our consciousness, in some sense, participating in the construction of reality? If the act of observation truly affects the universe, then we are not indifferent bystanders, but co-conspirators in the cosmic process. Our every glance is changing the world. So the question becomes, when we're not looking, is the world still there? In what way does it exist? Or is it that our consciousness is the spark that lights up reality? If reality needs consciousness to become clear, then what does free will mean? Is our position closer to the core of the universe than we imagine? There are no ultimate answers to these questions, but they lead us to a possible truth. Reality itself may depend on our existence more than we realize. Every possibility gives birth to a universe. The strangeness of quantum mechanics is that it doesn't just tell us that a particle will choose one outcome. It tells us that it might not make a choice at all, but rather live out all possibilities. This is the origin of the many worlds interpretation. It proposes that whenever a quantum event occurs, the universe splits. It doesn't quietly make a decision in front of you. Instead, all possible outcomes occur simultaneously in their own respective universes. In other words, every choice, every moment, is not a one-way street to the future, but a fork in the road. Countless parallel versions of you, in countless worlds, have taken different paths. Imagine you are about to toss a coin. In this world, it lands showing heads. But in another world, the same you sees tails. The coin lands in every possible state, and the universe splits for every possibility, expanding to generate new realities. This is a mind-blowing idea. Every choice you've made, every what if, every if only, is actually happening in another universe. This also leads to an ancient and sharp question. If all possibilities are realized, does your choice in this moment truly matter? Are we just wandering down one particular branch, merely an observer among countless versions? Or is it precisely the version you perceive and experience right now that gives you unique meaning and freedom? Perhaps free will is not about choosing whether something happens, but about choosing which universe to wake up in. So the question becomes, If there are indeed infinite universes, does that mean every version of you is alive somewhere, including the you who chose a different life path, the you who lost, struggled, succeeded, gave up, and loved without ever saying it? Is there still some invisible hand behind all this? Or is everything just the eternal calculation of math and probability? Ultimately, we can only open our eyes in this one reality, on one of these countless parallel lines, living out the us of this moment. Perhaps it is this sense of experience within limits that makes every decision we make worthy of being taken seriously. Can the quantum world allow both to coexist? In the long river of human thought, there's an ancient and unresolved question. Do we truly have the freedom of choice, or are we just passive actors in the universe's script? In Newton's worldview, the universe is like a precision clock. The movement of every gear is a product of cause and effect. Every future is already determined by the past. This is classical determinism. If you knew the position and velocity of every particle, you could predict the entire future of the universe. But quantum mechanics shattered this illusion of certainty. In the microscopic world, the behavior of particles is no longer a straight trajectory. They are like standing at a crossroads in life, taking all possible steps at the same time. Their state is not yes or no. It is superposition, a cloud of probability. It's only when we observe reality that it collapses into one outcome. Imagine you roll a die. In the eyes of classical physics, its landing spot is already determined by mechanical laws. But in the quantum world, it could simultaneously land on every side from 1 to 6, only when you open your eyes is the result born. This forces us to rethink our choices. Are they like that quantum die? If the universe, at a microscopic level, is not entirely predictable, do we then have a real space for choice? Or is randomness just a new script, the cradle of free will, or another illusion masking determinism? Some say that the uncertainty in quantum mechanics is just randomness, which is not the same as freedom, because free will is not just about being unpredictable. It also requires a sense of subjective participation, a consciousness of I have decided, but others believe. It is this very uncertainty that opens a door for free will. Behind this door, our consciousness is perhaps no longer a prisoner in the chains of causality, but a co-conspirator with some deeper order. And so we face a new philosophical path. If the universe has infinite possible branches, and if our choices can land us on different tracks of reality, then every decision is an act of world creation. The question then becomes, do we truly have freedom, or are we just walking on the paths laid out by quantum probability? Perhaps free will is not a miracle that escapes natural laws, but a crack left by nature itself for us to pass through. Could the universe possibly have consciousness? At the intersection of science and philosophy, a stunning hypothesis is emerging. Perhaps the universe is not an unconscious machine, but an awakening conscious entity. This idea does not come from metaphysics or mysticism, but from the integrated information theory proposed by neuroscientist Giulio Tononi. It's hailed as the most ambitious theory of consciousness of our time. It doesn't try to tell us what consciousness is, but rather, it tries to answer. When a system becomes conscious, the core idea of integrated information theory is that consciousness arises from a system's ability to integrate information internally. The more complex, highly connected a system is, and the more indivisible it is in the process of receiving, processing, and feeding back information, the higher its level of consciousness. Imagine a light bulb. When it lights up, it illuminates the room, but it has no self, because its information processing is linear, fragmented, and cannot be integrated. But the human brain is different. It has tens of billions of neurons, and every moment, it seamlessly integrates perceptions from the inner and outer worlds, memories, language, and emotions. Your consciousness emerges from this deep integration. So, if the brain's consciousness comes from information integration, what other systems might also possess consciousness? Integrated information theory proposes a staggering inference. Consciousness is not a uniquely human privilege. Any system with sufficiently complex information integration capabilities could possess some form of consciousness. This forces us to turn our gaze towards the universe itself. After all, is the universe not just a vast, interconnected system filled with interconnected structures and feedback mechanisms, from galactic networks to quantum fluctuations, from gravitational lensing to the effects of dark energy? Is its entire operation not essentially a form of complex information processing? If every corner of the universe is exchanging and processing information, and if quantum entanglement and coherence represent some kind of information integration mechanism beyond classical computation, is the universe, in some way, aware of its own existence? This is not to say the universe has eyes, language, or a personality. It means it might possess a form of proto-consciousness that we can hardly comprehend, a consciousness rooted in information itself. Imagine, our brain is just a subsystem, and the universe is the larger, deeper main system. If our consciousness is a product of localized information integration, then is cosmic consciousness the total integration of all information? If the universe itself possesses some form of consciousness, does it know that we are thinking about it? If consciousness is not unique to biology, but is a product of information integration, then are we living in a universe filled with proto-consciousness? If you can be conscious right now, does that mean a part of the universe is becoming conscious of itself through you? When we stand at the exit of the labyrinth of quantum mechanics and look back, quantum immortality has long surpassed the scope of a mere physical hypothesis. It's like a prism that refracts the light of life into countless brilliant facets. In each facet, there's a version of you breathing, choosing, and resonating with the strings of the universe. Perhaps we can never prove with lab data whether consciousness can truly jump between parallel universes, but this controversial theory has already opened a critically important door for us. It allows us to see, for the first time with such clarity, that the weight of life lies not in whether it is eternal, but in how every single moment is creating infinite possibilities. When you push open a window on some morning, the moment sunlight falls on your eyelashes, perhaps in countless branching universes, there are countless versions of you, simultaneously experiencing the warmth of this dawn. In some versions, you are about to embark on an adventure. In some versions, you are making peace with the past. In some versions, you have just been born. In some versions, you are already old. But all of you are collectively weaving a quantum web called existence. Each node shines with a unique spark of life. This might be the most precious insight that quantum immortality gives us. Death has never truly defined life. Instead, it's every fleeting moment of being alive that adds irreplaceable meaning to the universe. When we hesitate over a choice, weep over a farewell, or chase after a dream, we are not heading towards some predetermined end. We are participating in the splitting and rebirth of the universe. Every heartbeat is a resonance across countless parallel spacetimes. Every gaze is a gentle disturbance in the web of reality. So, there's no need to ask if there's eternal consciousness after death. Instead, look down at the time flowing in the lines of your palm. The love we've truly felt, the regrets, the courage, and the vulnerability, those subtle moments that make us who we are, have long since solidified into eternity in the quantum foam. When we learn to be fully present in every moment, we are, in all possible universes, living out the truest form of immortality. After all, in that quantum universe composed of probability and miracles, every version of you, in its own way, is making existence itself a never-ending source of wonder.